Okay, so the test is coming up, and here's the video that goes over everything that you need to know. Everything from the review. Fast forward to any question that you want to. Okay, it might be a long video, but you don't need everything probably. Maybe you just need help with a couple problems. So fast forward to those problems if you need. I'm going to go ahead and get started with number 1. So consider the statement 4 minus 3 plus 5 equal to negative 6 plus 8 plus 4. This is a mathematically correct sentence. Is this sentence true or false? How do you know? So we're going to determine whether or not this statement here is, it says it's true, it claims that it's true, but we're going to find out if it's true or false. So all we have to do is just evaluate and see if they do indeed equal each other. So for example, 4 minus 3 plus 5, 4 minus 3 is 1, and 1 plus 5 is 6. So that side is 6. And it says it's equal to negative 6 plus 8 plus 4. Negative 6 plus 8 is positive 2. Positive 2 plus 4 is 6. So that is also 6. So we have 6 equal to 6. So therefore, yes, it is true. Yes, it's true because 6 equals 6 after evaluating. Okay, that's just me kind of explaining what I did. I tell what my answer is. I'm saying that, I got 6 equal to 6 after I've worked it out. There's not a whole lot to show work for. It's just describing what happened. Now, number 2, there is some work to be shown in a few of these problems. Determine if the sentence is true or false. Select all that apply. So the first one, kind of similar to number 1, is just evaluate and see if it's true. See if the left side equals the right side. So the left side, 2 plus 5 is equal to 7. And the right side, 19 minus 12, 19 minus 12 is also equal to 7. So because 7 is equal to 7, that makes that a true statement. Now the second one, 4/5 plus 1/5 is just 5/5, which means it's just one whole. The right side, 2 minus 1 is 1. And then that minus 1 is 0. 1 minus 1 be 0. So that's equal to 0. So we have 1 equal to 0. Now that's obviously not true. So this one is false. Okay. All right, we keep evaluating. Number 3, 5 minus 4 minus 3 minus 2 minus 1. Working all of that out, 5 minus 4 is 1. Then 1 minus 3 is negative 2. Negative 2 minus 2 is negative 4. And negative 4 minus 1 is negative 5. So that side's negative 5. And then this side, 30 minus 34 is also negative 4. Then negative 4 minus 1 also makes negative 5. So negative 5 does equal negative 5. This is a true statement. Now, in the next one, I'm going to work it out, see what I get, and again, see if it's true or false. But we have x's here, so it's a little bit different. We got to see what happens with those. So if we multiply, we distribute, we get 2x. 2 times 8 makes 16, so 2x plus 16 equal to 2x minus 8. If I want to continue solving, I can. Some people might already know whether this is true or false by looking at it at this point. But if you don't see if it's true or false at this point, then let's just keep working it out. So my goal is to combine the x terms, this one and this one. I'm going to move the one on the left to the side on the right. So I'm going to subtract this 2x so that it cancels. And I get 16 here on the left. But on the right, 2x minus 2x also cancels and just leaves me with negative 8. So I'm left with a solution that says 16 is equal to negative 8. And just like 0 is not equal to 1, this is not a true statement. So this statement is also false. But it's important to note that the x is completely canceled out here. There's no x in the problem whatsoever. They completely disappear and just left us with 16 equal to negative 8. And this last one, we're also going to distribute. I'm going to change the color here so it doesn't blend too much with that last one. We'll change it to blue. All right, so same process as kind of before. We want to distribute. We want to simplify. 2 times x becomes 2x. 2 times 5 becomes 10. We have minus 4x we just bring down. We distribute this one as well. 3 times x and 3 times negative 2 makes negative 6. And then bring down the negative 5x plus 16. So I've just taken care of this parentheses. Just distributed the 2 to the x plus 5 and the 3 to the x minus 2. But now I've got some like terms to combine on either side. So I've got 2x and negative 4x. Now keep in mind, when they're on the same side, both of these are on the left side, we just put them together like we read them. I see a lot of times people will try to combine this, they'll do plus 4x and plus 4x because they think, oh, I'm going to cancel this 4x out and have it combined with 2x. But it's only if you're going to move it to the other side of the equal sign. These are on the same side, so just kind of, rewrite it as it's read. It's a 2x minus 4x. And 2 minus 4 is negative 2. So when you combine them, you just have negative 2x. No fancy things going on, no inverse opposite operations, just negative 2x. And then, of course, bring down the 10 because the plus 10 doesn't combine with anything there. The right-hand side, we still have other terms to combine. Same idea with these x's. They're on the same side together, so we just combine them together. 3 minus 5 makes negative 2x. And then we can also combine the negative 6 with 16. So negative 6 plus 16 is positive 10. All right. Now, again, this might be enough for some people to know whether it's true or false, but for the rest of us who can't tell if it's true or false, let's continue working. If it's all right with you, I'm just going to rewrite the problem over here on the right side. So I have a little more room. Negative 2x plus 10 equal to negative 2x plus 10. And so I'm going to try and add this 2x to the other side to combine it. So what that does is it cancels it out, brings down 10. But also notice negative 2x plus 2x, it cancels out here as well. So the x disappears completely, and I'm left with the 10 on the right-hand side as well. So just bringing down my 10s. And I get 10 is equal to 10. The x's are all gone. The x's all canceled out. But the difference is between this one and the last one is that this one is true. 10 does equal 10 and will always equal 10. So that statement is true. So now let's consider number 3. Consider x plus 4 equal to x plus 8. What values could be substituted for x to make this a true number sentence? Explain how you know. So we are just going to go ahead and just evaluate it. We're going to work it out and see what we get and then make a conclusion based off of that. So when I solve, I'm going to try and combine the two x's together. So let's try to move the one from the left side to the right side. So I'm going to subtract x just so I can cancel it out, right? X minus x is 0, so it disappears. I bring down this 4, and now let's look at the right side. We have x minus x, but that's the same thing that happened on the left. These cancel because x minus x is 0x. They go away. They cancel out. Those are gone, and I'm just left with bringing this 8 down. So I'm left with 4 equal to 8. Now, this is not a true statement, right? This is a false statement. But that's not what the question's asking for. The question's asking what values can be substituted for x. Well, if we pay attention, right, at the end of this problem, there is no x. X doesn't equal anything. And I'm left with a false statement. What that means is that the x is basically irrelevant here. No matter what I plug in for x, I will always be left with 4 equal to 8. I will always be left with a false statement. And since that statement is always going to be false, then there's no value of x I could ever use that would make it true. So this has no solutions because there's no value of x that I could ever use that would make it true because the x becomes irrelevant and I will always be left with a false statement. Now, consequently, just on a hypothetical here, if this was 8 equal to 8, I know it's not, but let's pretend it was. If it was, and it was a true statement, then it'd be the opposite. It would be all solutions. It'd be infinitely many solutions. And that's because the x's would still cancel out. The x's would still be irrelevant, so they wouldn't mean anything, but I would always have a true statement. So what that means is I could plug anything in for x that I want, and it will always be true still because the x's are going to be irrelevant and cancel out. And I will always have a true statement regardless of what I put in for x. So if it's true, then all values of x are true. Okay? But this one was false, making no x value possible to make it true. So therefore, no solutions. Now, number 4, consider the equations 5x plus 10 equal to 30 and 5 times x plus 10 equal to 30. Do they have the same solution or not? So there's several different ways you can go about it. But if we distribute like we would have to here, we'd have 5x plus 50 equal to 30, right? 5 times x makes 5x. 5 times 10 makes 50. Now, the other equation was 5x plus 10 equal to 30. I think anyone with a little bit of common sense might be able to understand that these are not going to have the same solutions. They're not the same equations, right? The 5x and 5x are the same, the 30 and 30 are the same, but the 50 and the 10, that's going to leave us with different solutions. If they were the same equation, we would have the same solution. But we're not going to have the same solution because they're different equations. So we're going to say, no, they'll have different solutions because 5x plus 10 is different than 5x plus 30, right? They're still equal to, or 5x plus 50, I should say. They're still equal to 30. Both of these are, but they're different setups. 5x plus 10, 5x plus 50 are different things. There's no way you can imagine that they would have the same solution. All right, look at number 5. Number 5 is very similar, but I'm actually going to work this one out. So consider the equations 3x plus 2 equal to 14 and 2 plus 3x equal to 14. Do they have the same solution or not? Now, you don't have to work this out. Just like the last one, you don't have to work it out to be able to see the answer. But I'm going to work it out anyway. And then we'll discuss how you can tell right off the bat whether they have the same solution or not. But if you can't tell right off the bat, just work it out and find out. So we have 3x plus 2 equal to 14. And we have 2 plus 3x. Oops, I wrote that down wrong. 2 plus 3x equal to 14. So let's solve them and see if they do have the same solution or not. So subtracting 2, we would have 3x equal to 12. And then I divide by 3, and I would have x equal to 4. Now on the other side, I would subtract 2, and I would have 3x equal to 14 minus 2 is 12, and divide by 3. So we end up with x equal to 4. So both solutions are the same. They both are equal to 4. So this is going to be yes. You know, you could say yes, they both equal 4. Okay. Now, here's how you can tell from the beginning. 3x plus 2 is the exact same thing as 2 plus 3x, because if you're paying attention, that's 3x plus 2, and that's also 3x plus 2. It's just written backwards. So they are literally the same equation. This is the same thing. That's 3x plus 2. That's exactly the same as the other one. They're exactly the same equation, so of course they'll have exactly the same solution. So that's something else you could say. Without working it out, you can say, yes, they would have the same solution because they're both the exact same equation. 3x plus 2 is the same as 2 plus 3x. And that's what you would type out. Now, number 6. Complete the following table with the correct properties. So we're looking from the first step to the second step. Going from here to here, what we had done, or what this person, whoever worked the problem out, had done, is they distributed. 2 times 2x makes 4x, and 2 times 3 makes 6. So they used the distributive property. And now we're looking at the next step down, from the second to the third. So they still have the 4x, but they got rid of the 6. The only way they got rid of the 6 is if they subtracted 6. 6 minus 6 would have canceled, and 22 minus 6 would have ended up being 16. So they subtracted 6 on both sides, meaning they used the subtraction property of equality. And in the last one, they got rid of this 4 because it's just regular x now. So they did that by dividing by 4. Dividing by 4 cancels out. 16 divided by 4 left you with that 4 there. So they divided by both sides. They divided both sides by 4. So divided, or I'm going to say division property of equality. Okay? I didn't change the color there, but it's okay. Number 7. Similar to the last problem, what we're doing, the following pairs of equations are equivalent. Describe the operation that occurred in the second equation. So here's the first one. We have 3 plus 9 equal to 12. Here's the second one. We still have 3 plus 9. We still have equals 12. But notice what's new in the second one. In the second one, they are subtracting 5. They have the minus 5 here and the minus 5 here. Everything else is the same, but the minus 5 is new. So they're subtracting on both sides, meaning they're using the subtraction property of equality. When we look at B, we have x minus 4 equal to 7. Then we have x minus 4 plus 4 equal to 7 plus 4. So notice they still have the x minus 4 equal to 7, but they're adding 4 to both sides now. So when they're doing that, let me use my colors like I did last time. All right, when they're doing that, they're adding 4 to both sides, so that's the addition property of equality. So now let's look at C. C, oops, I covered that up there. Okay. Let me close that real quick. Let me bring it back. All right. C, they have 2 times 6 equal to 12. Oops, hit the wrong thing. 2 times 6 equal to 12, and then they have 2 times 6 equal to 12, but notice the new thing, right? They're dividing by 2. Since they're dividing both sides by 2, right, that's the division property of equality. And then our last one, we see that both sides have that x divided by 2 equal to 5, x divided by 2 equal to 5, and here that's x divided by 2 equal to 5. But notice this one is multiplying by 5 on both sides. Or I'm sorry, multiplying by 2. The 5 was already there. Multiplying by 2, multiplying by 2. So since they're multiplying, that's the multiplication property of equality. Multiplication property. Okay, now we're going to solve equations. This is where some people might have fast forwarded because these equations can certainly be a bit of a handful, a bit of a challenge. So let's try to make sure we take our time. We're careful about it. I'm going to write down the steps that I do as well, just so that you can kind of see what I did in the order I did it. So the first thing I need to do is I need to get rid of these parentheses. The only way I can do that is to multiply that 6 into the parentheses. That's the distributive property. So number 1, distribute. We are going to distribute that 6. So 18 is still going to be there. 6 times 2 is going to be 12, so it's going to be 12x. And 6 times negative 8 makes negative 48. So that was just distributing. Step 2, I'm going to add 48. I'm going to get rid of the 48 by adding the 48 to the other side. So that's step 2. Add 48. So what that's going to leave me, that's going to leave me 18 plus 48 is going to be 66. And then I'll just bring down the 12x because the 48's gone on that side. So now I just need to divide by that 12. Dividing by 12 will get rid of that 12. It'll cancel that 12 out. Okay, so that's step 3. Divide 12. Now, after that step is over, we'll have x all by itself. Because the 12's gone, it'll just be x over here all by itself. And then we just got to simplify. 66 divided by 12 is 5.5. So your answer is x equals 5.5. All right, let's look at B. In B, we have to first multiply by 6. So step 1, multiply 6. Because that 6 is in the denominator, that means it's being divided. So the opposite of dividing a 6 is going to be multiplying a 6, which will cancel out that dividing 6. So, but we got to do that to both sides. So on the left side, all I'm doing when I write this 6 here, I'm just writing it there so I can cross it off and cancel it. I'm not really changing x plus 7. X plus 7 is going to stay there. Okay? And then 12 times 6, though, becomes 72. And then the second step, all I need to do is get rid of that 7, right? So it's adding 7, so I'll subtract 7 to get rid of it. 2 is going to be subtract 7. And this should give us our answer, because after the 7 is gone, the x will be completely by itself. 72 minus 7 is 65. So x equals 65. And now we have one more, and this one's a very tricky one. This one's really important, though, that we get this one right. So when we start, we're going to have to first take care of the parentheses, which means distributing that negative 2. Negative 2 times n, and negative 2 times negative 1. Everything else is going to stay. 12 plus 4n is going to stay. 8n is going to stay. It's just this negative 2 has to get multiplied to the parentheses. Now, -2 times n is going to become -2n. But let's be very aware of the also, -2 times -1. -2 times -1 is going to be a +2. So therefore, we'll have +2. Okay? So that's what we get when we distribute. So step 1, distribute. Okay, now step 2. Step 2 is combine my n's. I have 2n terms here that I can put together. 8n minus 2n. Just straight up, 8 minus 2 is 6. So that is 6n. Okay. I'm going to go ahead and leave my +2. Just bring that down. Leave the 4n, leave the 12, leave all that alone. Just bring all that down. I'm just combining those n terms. So combine n. Now, step 3 is also combining n's, but we have to do it across sides. So let me go ahead and write the fact that we're going to combine it again. Combine n's. But we're combining the 6n with the 4n. Now, to do that, we actually have to move it from one side to the other. So you have options. You can either take 6n and move it over here and have it join 4n, or you can move 4n over there. I'm going to move the 4n because I usually like to move the smaller one. Smaller one's usually easier. So what that does is it cancels out 4n, right? We still have 12. We still have 12 equal to, but now 6 minus 4 is going to be 2n, and then we still have +2. So we still have the 12, still have the 2. Just move the 4n, 6n minus 4n to make 2n. Now, step 4, I'm changing colors so that you can kind of see how each step is played out. So step 4 is now we're going to subtract 2. We're going to subtract this 2 to cancel that one out. So we're doing that on both sides. Now, when I do that and I simplify it, I'm going to have 12 minus 2 makes 10 equal to 2n. Okay, but that 2 canceled out, so we're just left with the 2n now. The +2 canceled out. And last but not least, my final step, I just have to divide by 2 to get rid of that 2, so that n is equal to 10 divided by 2, which is 5. So step 5 was divide by 2. All right. So now let's move on to number 9. Number 9, during summer vacation, you charge people $9 per hour for swimming lessons and then $15 registration fee. If you make $60 on one day, how many hours did you spend teaching? So think about it like this, right? You have $60. Now, 15 of that was from the registration fee, right? So if you take away 15, $45 is what's left over from the hourly rate, right? So since it's $9 per hour, if you take that $45 and divide it by the $9 you're getting per hour, that'll tell you how many hours you spent working. So that's one way to think about it. If you think about it from a practical standpoint, right? You have $60, you got 15 of it from just the registration fee, right? So if you take out that 15, that means the $45 left over, or the 45 other dollars you had made from the hourly rate. Since it was $9 per hour, dividing it by 9 tells you how many hours you worked. But let's do it the way we've been doing it in class. I just want to show you that case that made a little more sense to people, where my traditional explanation did not. But for the traditional explanation, here we go. You're making an equation for this information. So you have to pay a $15 registration fee up front. Now, in addition to that $15 registration fee, being charged $9 every hour. So $15 right up front, but adding $9 every hour of work. So 9h, 9 times h for 9 times every hour. And then this came out to a total of $60. So there's your equation, and you solve the equation, and it's doing the exact same thing that I just mentioned, at the beginning of this problem. Because when we solve this, guess what we need to do? We need to subtract 15, right? Because that's taking out that registration fee. So without the registration fee, it's $45. And then because it was $9 per hour, when you divide by 9, you get your hourly rate. Your hourly rate is equal to 5 hours. All right, because 45 divided by the 9 is 5. So you worked 5 hours that day. So you can approach the same thing. Number 10, you can approach it the same way. I'm going to go ahead and make the equation for it. So Alex is selling cars. He earns $200 every week plus an additional $50 per car. So he's making $200 flat up, right? Straight up. No matter what, sells 0 cars, he's making $200. But he earns another $50 for every car that he sells. So he's going to add $50 per car that he sells. Right? So 50C. And this is going to be equal to 950 since that's what he ended up making last week. So when we solve this, we subtract 200 just to get rid of that. And that leaves us with 50C equal to 750. And then just divide by 50. So this gives us, I believe it's 15. C equals 15. So 15 cars he sold. And you can see if that makes sense, right? $200 plus, $50 times 15 cars that he sold. And you can do the math and you can see, does that actually come out to 950? Yes or no? And it should. If I did it right, it should. If it doesn't, then we did it wrong, but I'm pretty sure that's right. All right, number 11. So solving using the zero product property is rather simple. All you need to do is take each part that's broken down and create its own equation equal to 0. So x plus 13, make its own equation equal to 0, and then x plus 7, it needs its own equation equal to 0. And just to show the consistency, the next problem does the same thing. You take each piece and you would set each piece its own equation equal to 0. So you'd have x plus 6 equal to 0 for that one, and then also 3x minus 1 equal to 0 for that one. Okay, but let's focus our attention back here at 11. We'll get back to number 12. So you just set up these equations equal to 0, and you just solve them. So you subtract 13 to solve the first one. We have x equal to negative 13. There's the solution. And then you subtract 7 from the second one. We have x equal to negative 7. So there's your second solution. Now for the other one, right, same idea. We have our two equations set up both equal to 0. Just subtract 6 to solve this one. X is going to be equal to a negative 6. Now this is the one people most messed up originally. You're still solving it. The process doesn't change. You would add 1 to cancel the 1 out, and we would have 3x equal to 0 plus 1, which is 1. But now you need to divide by 3. Okay, and we have x equal to, look at that, 1 over 3, which is 1/3. This is not the same thing as 3. If it was 3 divided by 1, then it would be the same thing as 3. But it's not. 1 divided by 3 is 1/3. It's also, 0.3 repeating. But it's a fraction. Leave it as a fraction. You don't have to do anything with the fraction. That's just what you're left with. Okay? Your answer just happens to be a fraction, and that's cool. Okay? We don't have to do any math with it. We don't have to do anything else with it. It's just chilling here. Okay? That's your answer. Okay. Number 13. So we're writing down here, we're going to write the inequality for each graph. I'm just going to go ahead and write it next to the graph just for, I don't know, sake of it being a little easier that way for me. So the first graph, we have an open circle at -2, and it's being shaded to the left. So what that means is that all the x values that exist here, these values, because it's shaded to the left, so -4, -6, all these numbers are less than -2. So all the values of x are less than -2. Now, since it's an open circle instead of a closed circle, it's just regular less than. Open circle has regular less than or regular greater than. a closed circle would be less than or equal to and greater than or equal to. So that's just something to keep in mind. Now, part B, the second part here, we have a closed circle, and it's also shaded to the left. So it's still less than, because -4, -6, all these numbers over here on the left are less than -2, but because it's a closed circle, it's less than or equal to -2. The third one, we have an open circle on -2 shaded to the right. So these numbers, 0, 2, 4, all of this stuff is bigger than -2. So x is bigger than -2. And it's just regular greater than because it's an open circle. Now the last one has a closed circle, and it's shaded to the right. So it's going to be x is bigger than or equal to, right? X is more than or equal to -2. So remember the closed circles? We're going to have that equal to portion, that little line underneath the the inequality sign. Whereas an open circle doesn't have that line under it, okay? It's just a regular greater than sign or regular less than sign. Now, 14, I'm going to solve, just so I have a little bit more space and don't get in the way of the number line, I'm going to solve it over here on the side. I asked you guys in class to solve it on the space that you had on the back of your paper. So, number 14, we have, let me write the problem down. We have 7 less than or equal to 5x plus 2 less than 22. So when we solve this, okay, our goal, okay, is to get x by itself in the middle. Okay, so in the middle, we have 5x plus 2. So we need to get rid of 5 and we need to get rid of 2. If we do that, then the x is by itself. So we do this one at a time. The first thing we're going to do is subtract 2. So minus 2. When we subtract 2, we're going to cancel it out. But we have to subtract 2 on all sides of this. Okay, in the middle, in the left, and the right. So 7 minus 2 is going to make 5. Still less than or equal to, but now since the 2's gone, it'll just be 5x in the middle. Less than 22 minus 2 is 20. So now I got to get rid of the 5. So since it's 5 times x, I will just divide by 5, and I can cancel it out. But don't forget, just like with the minus 2, we have to do the dividing 5 on all parts. So on the left side, 5 divided by 5 is 1. It's still less than or equal to, and then here in the middle is just x because we got rid of the 2, now we got rid of the 5, so x is by itself. Still less than, but 20 divided by 5 is 4. So there's our answer. So when we graph it, this says that x is between 1 and 4, and it's equal to 1 as well. So when we graph it, we'll have a closed circle at 1. And over here, we'll have an open circle at 4 because that inequality sign does not have the equal to part underneath it. So it's just an open circle at 4, and x is between 1 and 4. So we are shading between 1 and 4. So there's your graph of that. Now, part B, let me write this out. We have -4 greater than or equal to 12, or if 8 minus 2p is less than 12. Okay, since this is an OR problem, we have to solve both of these inequalities separately. So let's focus on the one on the left. The one on the left is just one step. I forgot the p part, by the way. I don't know if I accidentally erased it or not, but it's supposed to be -4p. All I got to do is divide by that -4. Since it's -4 times p, dividing by -4 not only gets rid of the 4, but it gets rid of the negative. Leaves you with a positive regular p. But of course, divide -4 over here as well. So that leaves you with p. Now, because you divided by a negative, divide by negative, we have to flip the sign. So our sign was greater than or equal to, but now it's going to be less than or equal to. And then 12 divided by -4 is -3. So we have this as the first part. Or let's work on the next part. So next part, we have 2 steps. We have the first thing, we need to get rid of 8. Since it's a positive 8, we get rid of it by subtracting 8, right? Because 8 minus 8 would be 0. So we're going to need to subtract 8 on the other side as well. This leaves you with a negative 2p is less than 12 minus 8. 12 minus 8 is 4. So just like we did here, we have to divide this negative 2, okay? So because it's negative 2 times p, dividing by negative 2 cancels out 2 and the negative. But don't forget to divide negative 2 on both sides, of course. So that leaves us with a positive p, but we did the same thing we did on the last problem. We divided by a negative. And since we're doing that, we need to flip our sign. So it's now, instead of less than, it's greater than. And 4 divided by negative 2 is negative 2. So its p is greater than negative 2. So now we have to graph it. We have, our answer is p is less than negative 3. I'm sorry, less than or equal to negative 3. Or p is greater than negative 2. So when we graph it, we have a closed circle at negative 3 because it's less than or equal to. Now less than is to the left, negative 4, negative 5, negative 6. All these numbers are less than negative 3. So we would shade them in that entire left side. For the negative 2 part, it's an open circle because it's greater than, not greater than or equal to. But greater than means all the numbers that are bigger than negative 2. Negative 1, 0, 1, all of these numbers are bigger than negative 2. So we would shade this direction. So you'll see that we're shading opposite ways. Right? We're shading to the left and to the right, and then there's that gap in the middle. And that is our graph. So number 15, write an inequality for each. So because I can tell that these are going opposite ways, I know that this is an or inequality. So I just have to write an inequality for each side. So the left side, these are all the x values. We're shading to the left. These x values are all less than or equal to, because it is a closed circle, less than or equal to negative 5. On the right side, we're shading all the numbers that are bigger than 5. So x is bigger than or equal to, because again, it's a closed circle, so it's got the little line underneath it, positive 5. All right, B is also an or problem for the same reason. We have the graphs going opposite directions. This one, I have an open circle, so that x is just plain less than negative 5. And it's less than because, again, these numbers, negative 6, negative 7, these are all numbers that are less than negative 5. On the right side, we have x, and we have another open circle, so it's just plain greater than. It's greater than 5, 6, 7. 6, 7, all of these numbers are bigger than 4, so it's x is greater than 4. Now, C is the only and one here because it's shaded in the middle. So because of that, you always kind of want to set it up with x in the middle. X is between which two numbers? X is between negative 5 and positive 5. Now, both of these are open circles, so both of these just have regular less than signs. If any of them were closed circles, it'd be less than or equal to. But they're not, so it's just regular less than signs. But that's how you would write it. X is between negative 5 and 5. And our last one, again, because they're going opposite ways, it's an or. So we have x, in this case, numbers are less than negative 5. And on the right-hand side, we have x numbers that are bigger than positive 5. Both of those are open circles, so both of those are just regular less than and regular greater than signs. All right, now moving on to number 16. So number 16, the first part can be a bit of a handful. Part A, but part B is, they're basically the same, but you'll see part B is just a little bit simpler because of a negative that we don't have to deal with. So in part A, we're going to solve for h. So we have x equal to r minus h over y. Now the first thing that we're going to do, because we're trying to solve for h, we need to get rid of r and we need to get rid of y. The first thing we're going to try and do is get rid of the y, because it's in the bottom, it's in the denominator, it's kind of in the way. So because it's in the denominator, right, that means divided y. So since it's being divided, we're going to multiply by y on both sides. So step 1, multiply y. Okay, so that the y in the bottom can cancel out. Now that leaves us, okay, y times x is just y times x. But I'm going to write it as x times y just because it's in math we normally do things kind of in alphabetical order. So xy, all right, equals to r minus h. The y is gone now, it's just r minus h. The next thing I'm going to do is I'm going to subtract this r, right? I'm trying to solve for h, so I need to get rid of r. So since it's positive r, I'm going to subtract r. So step 2, subtract r. Now what that leaves us is we have x times y minus r, right? That's what it says, x times y minus r. That's what we're going to write, x times y minus r. This equals, because there's a cancel, negative h. We still, unfortunately, have that minus sign there. Now, we have to get rid of that minus sign. So this is a -1 times h. That's why the minus sign is there, because the coefficient is -1. It's -1 times h. If we want to get rid of that, we need to divide by -1. Now, everything is getting divided by -1 here. Now, all this really does is it just changes the sign on all of them. A positive xy divided by a negative is just going to become a negative xy. A negative r divided by a -1 just becomes a positive r. And then, of course, the negative h divided by the -1 becomes the positive h. So it's pretty much the same thing, just all the signs change. So be very aware of that. So step 3, divide -1. Okay, sorry I didn't keep up with my colors there, but it's okay. Now part B, same equation. We have we have x equal to r minus h over y. But we're going to solve for r this time. So we need to get rid of y and we need to get rid of h. So just like last time, the first thing we're going to do is get rid of y. So we're going to multiply by y because it's the opposite and it'll cancel out. So step 1, multiply y. So what that leaves us, same thing in the last problem, right? X times y equal to r minus h. But now we need to, because we're solving for r, we need to get rid of h. Since it says minus h, we can actually add the h to both sides. So step 2, add h, right? So the h's can cancel. And that leaves us with our final answer. So we have, it'll be r all by itself, right? Because the h is gone. And on this side, we have x times y plus h. So x times y plus h. So there is our final answer. And now number 17, very similar question, different letters, but it's very similar question. We're going to solve for m. So we have 2p equal to m minus r over q. If we're going to solve for m, we have to do the same thing we did in the last couple of problems. It means get rid of this denominator. So since it's the denominator is q, multiply q on both sides, and that can cancel that q out. So on this side, the left side, we have q times 2p. So that just basically is 2 times pq, right? That's 2pq. Q times 2p is 2p times q. So it's all just multiplied together, so I just kind of wrote it all together, 2pq. All right, that's the same thing as that. But now, because the q is gone, that's equal to m minus r. So we're still trying to solve for m, right? So we need to get rid of this minus r. The opposite of minus r is plus r. So we'll add r to get rid of it. So what do we have? We have, on the left, we have 2pq plus r, right? That's exactly what this says. 2pq plus r, and that's equal to m. We have done it. We've solved the problem. That is our answer. And now, final question. Martha can complete 15 activities a day. She can choose between crafts and sports. So variable 1, we'll call variable 1, is what we don't know is what crafts and what sports. How many crafts and how many sports. So X will represent the number of, let's say, crafts that they do. And we'll let Y be the number of sports that they do. So the equation, because they're doing 15 activities, is the number of crafts, X, plus the number of sports, Y, is equal to 15 activities. So if you add up the total between them, you would get 15. So a couple combinations, just basically 2 combinations of crafts and sports that would make 15 activities. You can have 3 crafts and 12 sports, and that's 15 activities. You could have 8 crafts and 7 sports. That would work. You could also have 14 crafts and 1 sport, right? Together you have 15 activities. You just have a variety of crafts and sports. Now, before I graph it, we're going to go ahead and mention that this is discrete. Discrete means that you can only have whole numbers representing it. So if you're planning your day, right, and you're going to plan 15 activities, you're going to plan whole number of crafts, whole number of activities. You're going to say, hey, we're going to do 3 crafts and 12 sports today. We're going to do 8 crafts and 7 sports today, right? You're only going to use whole numbers. You're not going to say, I'm going to do 8.7 crafts today, and I'm going to do 6.3 sports. You don't do that. You're only playing you're only doing these activities whole numbers. You're just counting these activities. So it's discrete because it's not going to be something that you can have kind of decimals for. So discrete because you can't have partial of an activity, okay? Because activities are counted with whole numbers. Essentially, right? Because you can only have whole numbers. You can only count the activities you do in whole numbers. You're going to have 3 crafts, 12 sports, 5 crafts, 10 sports, etc. Those, you can count how many of each thing you do. Okay, and you can only count them in whole numbers. You can't do 1.1 crafts. Okay, you're doing the whole activity. Now, on my graph, some people went by 5. Now, I went by 2, but there's a lot of people that went by 5. That's okay, but let me show you how detailed you still need to be, even if you go by 5. I'm going to go by 2, though, because it's going to give me a little bit more room for detail here. So this discrete graph is not a line. What we're doing is we're plotting every single possibility for our crafts and sports combinations. So for example, if this represents crafts and this axis represents sports, then I could do 15 sports and 0 crafts, right? I could do 14 sports and 1 craft. I could do 13 sports and 2 crafts, right? And every combination thereon, right? I can do 12 and 3. I can do 11 and 4. I can do 10 and 5. I can do 9 and 6. I can do 8 and 7. I can do 7 and 8. I can do 6 and 9. I can do 5 and 10, 4 and 11, 3 and 12, 2 and 13, 1 and 14, or 0 and 15. That is every single possible outcome on that graph. So if you do it by 5s, keep in mind you still have to graph every single outcome, but you won't have as much room for the detailed here. But let me just remind you that a discrete graph has only points. Okay, there's no line. I do not connect this with a line. Okay, only points for discrete graph. If it's continuous, then you have a line. If it was continuous, then you would put the line there because you're saying every little value in between those dots counts. But here, these gaps exist for a reason because we can't have those decimal values, those fractional values there. We can only have the whole number values. We're only plotting the points on the whole number values. Okay. All right, that's it. So good luck on the test tomorrow, guys. I'll see you next time. Bye.